Okay, good afternoon class. So today we're looking at analytical geometry. So we're looking at this point we have done example 1 on page 93, 193. Okay, so we're looking at worked example on page 194. Okay, so this is for exercise 100, exercise 2 on page 196. Okay, so here we are told that worked example 2, determine whether the line y equals x minus 5 is a tangent to the circle x squared minus 4x plus y squared equals 5. This example is on page 194. So remember, a tangent touches the circle at one point only. Thus, it will only, there will only be one point of intersection between the two graphs if it's a tangent. If it has more than 2 points of contact, then it will be a secant, or a secant. A line which passes through the circle, intersecting the circle at 2 points. So if you got two x values, two y values, it will be a secant. Or if it's touching at one point only, of course it's a tangent. So let's do the calculation quickly. So wherever we see a y, so that's basically equation 1 and equation 2. So wherever we see a y, we replace it with x minus 5. So there we go, so it's x squared minus 4x, we're doing simultaneous equations, plus x minus 5 squared is equal to 5. Which gives us x squared minus 4x plus x squared minus 10x plus 25 is equal to 5. Which now gives me 2x squared minus 14x. Bring that over, becomes positive 20 is equal to 0. Divided by 2, it gives me x squared. I think I made a mistake somewhere. Okay, so it's going to give you 7x plus 10 is equal to 0. So I got two solutions for x here. So I got x and x, 5 and 2, minus minus, so x equal to 5 or x equal to 2. Is that correct? So at this point, people, if you got two solutions, what does that mean? It's a secant. Okay, therefore, y is equal to x minus 5 is not a tangent to a circle. Right? Do you guys understand? So do I need to calculate the corresponding y values? No. Okay, because the question was if it's a tangent or not. Okay. Alright, let's look at example 3, and example 3 is on page 194. Okay, so something you need to consider here. Okay, something you must consider here is that before we go into this here, some theory you must consider. If you got two circles, okay, we've got two circles, okay, and these circles, you make it touch, okay, and of course this is the center of the circle. We've got two centers, no? So let's call this one A, so it's small, okay, A, and B, okay. So, people listen, if this is R1, okay, and this is R2, okay, if R1 and that is R2, né? If R1 plus R2, the distance of R1 plus the distance of R2, or the length of R1 and R2, which is the radius of the circles, if that is equal to the distance AB, okay, then what can you conclude about those two circles? They touch each other at one point. Can you see that? If the sum of the two radii is equal to the distance between the two centers of the circles, if that is the case, then the circles touch each other at one point. So make that note. Okay. The other end, we've got two circles. Okay. We have two circles. We have two circles. And this is now R1, R2. Okay, that's still B and A. If R2, and that is R1 now. Okay. So what note are we going to make here? If R1 plus R2 is equal to, is less than. Can you see if the distance between A and B will be greater than the sum of R1 and R2? Can you see that, people? Can you all see that? Okay. So if the sum of the two radii is less than the distance between the centers, then what can we say? Or we say the distance between the two centers of the circle is greater or larger than the sum of the two radii. The circle does not or doesn't touch each other. Do you see that? So if they ask you to prove that the two circles does not intersect each other, then we prove that the distance between the two centers, is larger than the sum of the radii. Then they won't touch each other. Okay? We ask you to prove that the two circles touch each other. We prove that the distance between the two radii is equal to the sum of the two radii. And the distance between the two centers of the circle is equal to the sum of the two radii. Okay? Okay, so writing. Alright. Go with the third one now. Oops. Third scenario. What do you think is going to be the third one? Where they're actually overlapping now. Not so. So let's go here. If that is A. No, that's not A. That is B. And this is A. Remember, that is radius 2, and from there to there, it's normally a straight line, that's radius 1. So what do you notice here now? What do you notice now? That the radius 1 plus the radius 2 is actually larger than the distance between the two graphs. Can you see that, people? So now we can clearly see that the sum of the two radii is larger than the distance between the two centers. If that is the case, what do we say? They cut each other at 2 points. Okay, so they intersect each other at 2 points, or whichever way you want to now say. Okay. Right, you guys got it? Now with that information, with that understanding, let's look at example 3. Let me take this off now. I'm moving too fast. Okay, take that one too. Okay. So now we're looking at example 3, and example 3 is on page 194. We are asked to show that x plus 3 squared plus y minus 4 squared is equal to 4 touches the circle, x squared plus y squared equals 9. So in that case, what are we proving? We're proving that the distance between the two centers is equal to the sum of the two radii. That's basically what we're proving. Can you see that, people? So in other words, I need the centers of the circle. This first circle center is the center of the circle, negative 3 and 4. What's the radius? The radius 1. Remember that is r squared is 4. So it's going to give you 2. So what's the center of the second circle? 0 and 0. What is the radius of the second circle? Remember that is r squared. So it's going to give you 3. So what is r1 plus r2 equal to? r1 plus r2 is 2 plus 3, which is 5. Now we're going to work out the distance between the two centers. Nothing on top means to say distance, okay? And how are we going to calculate the distance? Using distance formula. So I'm going to say negative 3 minus 0 squared plus 4 minus 0 squared. That gives me an answer of the square root of 25. Square root of 25 is 5. Okay. So what can we say, people? So we state the obvious. We say since R1 plus R2 equals the distance between the two centers. Therefore, the two circles touches each other at one point. Okay. Therefore, the two circles touches each other at one point only. Okay. Any confusion, people? No? Let's look at the next one. Now example 4, and example 4 is on page 194. Okay. So in example 4 we are told that you are given circle x squared plus y squared minus 4x plus 10y equals 7 with tangent PQ touches the circle at P. If Q is 8 and 3, determine the length of PQ. Okay, so when you are given a circle where it's not given in the standard form that we normally work with, which is x minus a squared plus y minus b squared equal to r squared. If it's not given in that form, we need to get it in that form. Okay. So that's the first thing I'm going to do, so that I can make a sketch of basically what's happening here. So what I'm going to say is going to be x squared minus 4x. I'm preparing to complete the square with, to complete the square. So it's plus a number, plus y squared plus 10y plus the first number is equal to 7 plus the first number plus the second number. Okay. And what is the first number in question here? It's going to be b times half, which is 4 times half, which is 2, and 2 squared is 4. What is 10 times half? 5, and 5 squared is 25. So that is my perfect square trinomial, and there as well. So this can be written as x minus 2 squared plus y plus 5 squared is equal to 11 plus 25 is 36. So what's the center of the circle? What's the coordinates of the center of the circle? 2 and -5. What's the radius of the circle? 6. Okay. So just reading what they gave us again here. Circle center, given circle with that equation as a tangent PQ. So we draw a tangent here. PQ touches the circle at P. So that has to be P there. So then what is this point here going to be? Q. Where Q is 8 and 3. You see that? Determine the length of PQ. So what do? I complete the triangle here. Can you see that, people? I have CP to be 6. What else can be calculated here? How can you calculate PQ? Distance formula. We don't have P? CQ is. Nice, you're looking up once and you got the answer in front of you before you go down. Proud of you. Right. So CQ, distance formula. There we go. 2 minus 8 squared plus what? -5 minus 3 squared. So work that out, what do you get? You get the square, the square root of 2 minus 10. Right, so that gives us 10. Okay, but they haven't answered the question. Now what do they want? PQ. Now we're going to calculate PQ. But like this. But where's the 90? Where's 90?
Oh, it's so funny.
There we go. We must first say C PQ is equal to 90 degrees. Why? Radius perpendicular to tangent. Not so? So now I can apply Pythagoras. Okay, so what can we say? QP squared is equal to 10 squared minus 6 squared, which is 100 minus 36 is 64. The root of 64 is 8. That's 8 units. Okay. You guys understand? Alright, so we'll stop here for today. So from exercise 2 you should be able to do number 3, number 4 and number 5. Okay? So example 5 and 6. No, example 5. And the next example I'll do in the next lesson. Okay? So I'll stop the video here. Yes?